Why can black holes tear apart everything in the universe? What happens to matter that gets sucked into a black hole? Where does it ultimately end up? We know that a black hole is a mysterious object, invisible to the human eye. Its gravitational pull is extraordinarily strong. When a planet enters the domain of a black hole, it is immediately captured by its immense gravity field. According to Newton's law of universal gravitation, the strength of gravity depends not only on mass, but also on the distance between objects. This means the side of the planet facing the black hole feels a stronger pull than the far side of the planet. This difference in gravity is called tidal force. It causes the celestial body to be ruthlessly torn apart by the black hole. It is then stretched out into a shape like a noodle. This is the so-called spaghetti effect. Do you see that striking glowing ring? That is formed when a black hole devours matter, creating an accretion disk. Before countless fragments fall across the event horizon and are swallowed completely, they first orbit around the black hole at lightning speed. Through constant friction, they emit blazing, brilliant light. This is one of the ways we can observe black holes. In April 2019, the Event Horizon Telescope captured the first ever photo of a black hole in human history. It was made public. This black hole is located at the center of galaxy M87. We can clearly see a bright glowing ring, but not the black hole itself. So in that case, does everything sucked into a black hole really mean total disappearance? In fact, Einstein's theory of general relativity mentions that gravity is the curvature of spacetime caused by mass, and the curvature of spacetime inside a black hole is nearly infinite. All matter that falls in is ultimately crushed into powder. It then falls into the singularity at the center of the black hole. But once matter flows into the black hole's center, where does it go? At present, we cannot observe it, nor can we know. After all, the escape velocity inside the black hole's boundary exceeds the speed of light. All information is completely locked inside. Even time itself cannot escape a black hole. Therefore, the ultimate mystery of what lies inside remains unsolved by science. But we can be certain, when a black hole swallows a celestial body, its mass increases. The more it devours, the larger it grows. Like an endless abyssal monster that can never be satisfied. However, black holes are not eternal. The famous physicist Stephen Hawking proposed that black holes slowly evaporate through Hawking radiation. A black hole with the mass of our Sun would take 10 years to fully evaporate. Although the process is extremely slow, it tells us something important. Everything in the universe, not only humans, but even black holes, will eventually come to an end.